With this tutorial, we want to explain the process of creating new CobiGen external plugins. Throughout this video, we will be heavily relying on the introduction to CobiGen external plugins, which is part of the CobiGen documentation. So feel free to follow through using this page, or just give it a read if you feel like you need any more information. Recently, there has been a major change in the CobiGen architecture to facilitate the creation of external plugins. As you can see from this figure, it is now based on a client-server model where the client is responsible of sending one or several input files to an external server, which has the two important tasks of either creating a model out of the received files or merging their contents. The result is then sent back to the CobiGen client, which uses a template engine to generate some output file according to the matching templates. In the following, we will try to develop a Python plugin as a demonstration example that is able to parse Python code and use it for file generation. The plugin will mainly consist of three elements: a server that is able to parse Python code into an abstract syntax tree and is also able of merging Python code, a CobiGen client that communicates with the external server and is responsible for file generation based on the templates, and the third and final element is the templates that should work with our new plugin. Now we move to the server implementation. As the server communicates with the CobiGen client through a REST API, it could be written using any programming language of your choice, but it should fulfill the REST API contract, which is accessible through this link. As you can see, the contract is written as a YAML file. You can obtain a better representation of it using this Swagger editor. The contract states that our server should run on port 5000 of our local machine and should respond to the following requests. One GET request on the topic process management to do plugin is connection ready, which will be used for connection establishment, and 3 post requests for checking whether the input is valid, for returning the parsed model, and for merging Python code in this example. Our Python server is based on the Flask library, with which one can easily and quickly implement and deploy such APIs. You can see that the complete implementation is just the logic needed for each of the requests, as defined in the API's contract. As there are no restrictions concerning the choice of the programming languages and the used frameworks, we won't go into further details about server implementation, and we will move to testing whether it is working fine. So let's run the server. For testing, we will use Postman. We start with checking whether a server is up and running with a is connection ready GET request. You can see that we send a GET request on the topic process management Py plugin is connection ready, as defined in this contract. And we get a true as a response. Next, we'll try to get the AST of this simple Python snippet. So we try to pass this simple assignment with the get input model post request. You can see that the body of our sent transfer object is composed of file name, content, and char set, and this is specified by the contract. You can see from the response that we get the file path back and the AST of the simple assignment as the parsed model. Once we have finished testing the server, we can now move to the implementation of the CobiGen client. Unlike the external server, we do not need to start from scratch here, as we have some sort of base for this CobiGen client, which we can access using this link and use it as a template. We choose CobiGen by plugin as a repository name and create it. Once this repository is generated, we can clone it. And then go into Eclipse and import it as a Maven project. You can see that the project is successfully imported and it has all needed files. You can see that there is some to-dos in the file names and in the package names that need to be modified with the correct plugin name. We can do this with refactor, rename. So we'll replace to do with pi in this example and leave all options checked. This should be done for all package names that have to do in them and for all Java files. Next, we need to go into this POM file and change the plugin name. After that, we should go to this to-do plugin activator and replace the trigger type with Python, for example, in this case. This should also be done for this package, the testing package, and the testing files. And for testing resources, we should have some valid input. So as we are dealing with Python right here, we should have some valid Python files instead of these base file point to do and patch file point to do. So we should have like some base file point py, which ends with a valid Python extension and which has a valid Python content. And please don't forget to change the to-dos in the test file with the appropriate file names. So point py in this example. As I already have done this, I will show you how the complete Python plugin should look like. So as you can see, we have replaced the to-dos with Python. We have Python as a trigger type, and if we run the tests, we expect that they pass. Okay, that was all for the client side.